Hello. This is the Reimagining Large-Scale Migration Planning with Agentic AI session, so hopefully you're all here for that. So what do we mean by reimagining migration planning? Migration planning has traditionally been a very manual process. Migrations take a long time. There's a lot of information in various places, and you create large teams, and you share information with each other, write scripts, figure out, in Excel spreadsheets how to do migrations. But with the advent of generative AI and very, agentic AI assistants, things are changing quite a bit. The assistant, the human being that you used to interact with to figure all these things out, can now be an agent. So you could use agentic AI to really do your migration planning a lot more seamlessly, and that's what we're going to talk about here today. My name is Tushar Saxena. I lead the AWS Transform migrations service team.
My name is Jonathan Shapiro-Ward. I lead discovery, assessments, and planning as part of AWS Transform for migrations.
Cool. So our agenda today, we're going to figure out why, we're going to talk a little bit about why you want to migrate. That's an important piece before you begin a migration, is to know why you want to migrate. Then we're going to talk about migration planning itself. And when I say migration planning, you might have a 5,000 or a 10,000 server on-premises estate with all kinds of complex network technologies, 600, 800 applications. You need a solid plan before you embark on migration. So how do you develop that plan with agents? We're going to talk about that. Then Jonathan's going to talk about AWS Transform, which is our new agentic AI service to not only help you create plans, effective plans, but also help you migrate all the way end to end, from discovery all the way to rehosting. And then we're going to talk about some best practices for accelerating your migration. So finding out your why. Before you even start your migration, it's important to know why it is that you want to migrate. If you're not absolutely sure about your motivation for migration, more than likely your migration is going to fail. Not because something went wrong with migrations, but because you don't know where you want to know where you are headed before you embark on the journey. So there's many reasons why you might want to migrate. As we've worked with customers over the last decade on migrations, cost comes up a lot. Customers want to reduce the cost, operating cost of their workloads, and so they want to migrate to the cloud. That could be one reason. There might be some temporal reasons as well. You have a data center exit you want to execute within the next 6 months. There might be some licenses that are expiring in the next few months as well that might create an urgency for you to migrate. Or you might just want to have the capability to innovate a lot more. Having a legacy system on premises has its own tech debt, and it prevents you from innovating with the latest technologies such as Gen AI, and so you might want to move to the cloud so you can innovate faster and quicker as well. So there's many different reasons why you might want to migrate, and oftentimes it's not one reason or two reasons. It might be a bunch of reasons why you want to migrate. So you want to be sure up front, why you want to migrate, and you have the buy-in from your leadership as well as from your colleagues within the company as to alignment on the reasons for why you want to migrate to the cloud. And once you know why you want to migrate, it's important to also know, most of the whys can be tied to some kind of a metric. So you want to be able to define metrics that can tell you how successful you are being at migration. Migrations can take a long time. Priorities can change. It can take months sometimes, hopefully with agentic AI, weeks. But even so, as the migration is proceeding, you want to make sure you have metrics that tell you whether or not you're on the right path or not, you're being successful or not. So these metrics are going to be important. There's many different types of metrics. Cost savings, again, as I mentioned, that might be an important metric to track. So as you are developing a migration plan, you might want to weigh, if I were to do this plan versus that plan, how would my cost change? If I were to use these EC2 instances to host my applications versus that, how would my cost change? You might want to lower the time to market You have, let's say you have competition that's coming up with innovative services. You want to move to the cloud quickly, so you have a market mover advantage or whatever. So there might be timeline reasons why you want to move, and so you might want to measure how much time to market you want to lower as you move to the cloud. Or you might want to increase the amount of staff that is working on innovative things. And so once they move to the cloud, there are fewer staff members you need to focus on the infrastructure and the non-innovative stuff, because the cloud can take care of that. And so you might want to increase the percent of staff that is focusing on innovation as well. So there can be many different reasons, but it's important to have these metrics defined up front. And then, most importantly, does your leadership understand why you want to migrate as well? Most successful migrations, you want to have strong buy-in from the leadership. This is an important move for a company. You're taking your on-premises workloads over to the cloud. Almost everyone in the company is going to be impacted by it. And so, you want to make sure not only is your leadership, that you have the buy-in from the leadership, but you have the buy-in from all of your business units and colleagues as well. So with that, that's sort of, these are the ingredients of a successful migration. Leadership buy-in is the first precondition, but it alone won't make the migration successful. There are constraints as well. So, if migrations, you might have too few constraints, then a migration can fail as well. For example, if you're not time bounding your migration, then it can go on for a long time. And Jonathan likes to remind me of Parkinson's rule, which is that if you increase the time, work comes in to fill up that time as well. So you will have people sort of doing busy work that's not contributing to your migration. So you wanna make sure you're also you're aware of what the constraints are within which you want to execute the migration. And then most important thing, once you have the why, once you have the metrics, and once you have the constraints with which you want to migrate, as we get into the agentic AI migration planning, these are sort of non-structured, sort of human understandable concepts that you want to then feed into the agent that Jonathan is just going to talk about. And the good news is that with generative AI and agentic AI, these concepts of why you want to migrate, what the metrics are you want to target, and what your constraints are, they can be interpreted by the agent that we're going to talk about today, and incorporated into the migration plans that it proposes to you, and you can iterate on that plan as well. With that, I'm going to hand it over to Jonathan to talk about migration planning.
Thank you. So, as Tushar just described, those are the preconditions for your plan to succeed. But ultimately, you need a plan. The plan is fundamental for your migration to be successful. It sets the timeline, the outcomes, the goals that you're seeking, and helps your migration to stay on track. So what we're going to talk about, firstly, is the general principles of building a plan. And then we're going to go deeper into how you can accelerate building a plan with AI agents, and specifically with AWS Transform for migrations. So at a general high level, the basics of building a migration plan consist of roughly 4 high-level steps. To begin with, you need ground truth. You need discovery data, ultimately. What that means is uncovering information from your on-premises environment. So that includes a combination of both tech and non-technical data, which we'll get into a little bit more, but ultimately that serves as the information that feeds the rest of your migration plan. Now, once you have an initial set of discovery data, it then becomes a case of assessments. Assessment can mean many things. We'll get into that a little bit more, but what typically an assessment means is TCO assessment, total cost of ownership assessment, ultimately providing the financial basis for your migrations, working out what the current state is on premises and what the cost will be on AWS, and not just the pure cost, but the optimized cost, so how you ensure that you are managing your costs and realizing cost savings as part of the migration. That typically serves as the basis for the cloud financial model and one of the key metrics for success for the migration. And once you have the basics of your assessment, it then becomes a case of wave planning, which will be a topic we'll get into a lot throughout this talk. Wave planning, put simply, is the process of taking everything that you have on-prem that's in scope for migration, analyzing it, and then ordering it into discrete sets of groups that can be moved independently and executed. It serves as the basis for your migration execution. Now, lastly is agile planning, because ultimately, something that I really want to stress that will come up a few times in this talk is that a migration is an agile project. You should treat your migration as you would any software engineering project and apply the same tenets and principles that you would to the majority of software projects. Think agilely and think about how to enact your wave as an agile project. And that involves setting up all of the ceremonies, managing your roadmap, your backlog, doing retrospectives, all of that good stuff, and thinking about how to employ the mechanisms that will keep your migration execution on track. Now, critically, this is not a one-and-done process. That it's a cyclical process. When you start with discovery, that is uncovering some initial information. Often we see customers start with something like an RV tools file. So if you're not familiar, that's a basic export from a vSphere, a VMware environment that contains basic inventory, or it could be something like a simple CMDB cloud change management database export. And that provides enough information to get a basic assessment going, to do some basic planning. But typically, as your migration progresses, maybe you start doing a few proof of concepts, maybe move one or two simple POC waves. You start to need greater detail, to do more detailed planning, to get more detailed understanding, because realistically, non-trivial applications are, by their very definition, complicated. They have complex dependencies, complex communication patterns, complex RTO and RPO requirements. And to understand that, you need more data. So you're going back to discovery, getting more data, and then as you get more data, you've got more data to fuel your different assessment types with, your TCO and other assessment types. You're fueling that information to your wave planning, which that updated wave plan then feeds into your agile plan. You update the stories that you're working from, you change your estimates, and so forth. So that at a high level is the general process. I'll go into that process in a little bit more detail, and then we'll talk about how you can use AWS Transform to accelerate the execution of this process. Because this process that we see here is something that customers are doing currently in months and years if they're doing it manually. Very commonly we see this done as a manual program involving consultants, program managers, engineers executing this at scale. And what we want to investigate here is how can we make this go faster? How can we get the time to value for your migration as down as possible? Before we get onto that, let's go a bit deeper. So let's understand these steps a little bit more. So firstly, I've mentioned assessments, and I've dwelled a little bit on TCO assessments. That is typically the absolute essential assessment type, because without having a good understanding of your costs, there's a major risk to your migration. I would say, after the first risk, which is the one that Tushar mentioned of not understanding your why, your reasons for migrating, after that, lack of cost management is probably the most common reason we see for a migration getting derailed. When we see costs exceed expectations, or simply costs are not managed and there is no based on expectation, that creates risk for the migration. So performing a TCO assessment to understand those costs and then to track them throughout the migration is indispensable. It's an essential component of every migration. However, there are other assessment types as well that are important, and these typically vary by customer to customer, business to business. Many customers need some form of specialized assessment. So for example, we see typically large enterprises often have some sort of compliance need or some sort of security review. Typically, these are assessments that are not entirely related to TCO. They may have no cost component at all. Often these are done with an AWS partner or AWS professional services, and they help provide additional supplementary insight into your current disposition on premises and inform your migration strategy. And then lastly, the third common bucket of assessment type is what I call a people and process assessment, where you want to analyze your current organizational strategy. You want to look at potentially things like your change management process, your finance, your operating models, analyze those factors and figure out how to transform them for better operating on the cloud. And you may need all of these, you may need a TCO assessment, but it depends on your particular challenges that you face on premises. Now, one thing that I do want to emphasize is the TCO assessment, really essential for understanding costs. Being able to track those costs and reduce the costs are particularly important. So that reduced cost angle, one of the things that really is important for that cost tracking is that workloads on premises typically are heavily over-provisioned. That what we observe most commonly is that on-premises machines are provisioned often for peak. We see this most commonly in places that have any sort of seasonality in their workloads. Most significantly, you can see this in places like the retail sector, where you provision infrastructure for peak utilization. You think about your Black Friday demand or your Christmas sales or what have you, and you're provisioning your infrastructure to meet those peak demands. Now, if you were to simply migrate that infrastructure as is to AWS, what you'll typically find is that your costs are in excess of what will be desirable. Instead, the best practice is to right-size, as the term goes. And what right-sizing involves is matching to the demand curve of your actual utilization. So if you are only needing 200 cores of CPU compute, you size that to the appropriate number of virtual machines, of EC2 instances, of Lambda functions, of what have you. And then if you have seasonality, you use the inherent elasticity of the cloud, things like auto-scaling groups, to manage that demand to meet the demand curve as it undulates. And that is something that you can do manually, but is particularly challenging to do manually. Typically, that involves a lot of manual analysis in spreadsheets and so forth. So being able to do assessments in an automated way is particularly valuable. We'll talk about exactly how to do that in just a moment. Now, once you've done the assessment, something that typically straddles the line between the assessment and the planning stage is dependency analysis. Now, this slide is moderately horrendous. It's very hard to make out what's going on there, and that is in some point the point of this slide, that what this is a visualization of a TCP trace. It's a semi-real environment where we're looking at the communication of different machines within the environment. And it's very hard to make heads or tails of this. But understanding the communication patterns and the dependencies of everything in the environment is incredibly important, because ultimately what you don't want to do is to break apart some of that communication and then find that, well, my critical application, my mission-critical system no longer works. So understanding these dependencies are essential. But trying to do this manually by hand is a huge challenge. I've seen customers try to do this in spreadsheets through manual analysis, and it is possible, absolutely. Through graph analysis, through all sorts of manual tools, but it is a huge time-consuming slog, and it's error-prone. Miss a dependency, risk a wave failing to complete, you have to roll back. So this is a huge opportunity for generative AI to help us with. We can use LLMs to solve this problem instead of doing it manually. But nevertheless, dependency analysis is a critical step which powers the way plan. So once you're doing your dependency analysis, what you're attempting to do is then identify applications within your environment. Now, those applications might be predefined. You may have a good CMDB, you might have a good application inventory. That does happen, but very commonly what we'll see is that customers have had many generations of technology investment. Some of their applications could be decades or more old, and being able to actually get a full handle on what's in the on-premises environment can be a challenge. Things like CMDBs or wiki pages or logs or what have you could be significantly out of date. So actually developing that application portfolio and getting a full handle on what's in the environment is a step that needs to be done. You can't just trust the data that's available. So first step is building that app portfolio, understanding these are my apps. And by apps, I don't inherently mean an application. It often is simply an app, but really what I'm meaning is a unit of business value, something that underpins a business function. Typically that's an app, but whatever it is, that is the unit of commonality that you care about in your environment. Once you've established that, which I'll call for an app for simplicity's sake, the question then becomes, what are the dependencies between those apps? And that's where your dependency analysis starts to feed into this. That what I want to know is that my application over here has a shared database with my application over there. I can't move these apps independently because they both have dependencies on stored procedures in this database. If I move them apart, something will break, critical business functionality will go away. So I need to move those together. Well then, wait a minute, that database has a backup over there, it's got a replica over here, so I need to understand the full extent and the boundaries of my system such that I can understand what has to be moved together. And likewise, when I'm trying to resolve these dependencies, there's also the question of what doesn't have to be moved together. So, for example, database dependencies, critical. However, something like an HTTP dependency, a web API, typically more latency tolerant. They don't have to be so tightly coupled as a database. Often you can split apart a web app, and that can go over a VPN or a direct connect between on-premises and AWS, so more tolerant. So understanding the limits of your application and those dependencies is the next important step. And then lastly, is then taking your application groups, typically what we refer to as the dependency groups or move groups, and then ordering them into waves. So that is ultimately the wave planning process. Now to clarify quickly in terminology there, because I use some terms there. So applications, units of business value, whatever you want to call them, ultimately those are the components that you care about. Those are the things you want to move from on-premises to AWS. You then have all of the communications between your apps that depend on each other, that database dependency or those web app dependencies. That's what we call the move group or the dependency group. I'll be using these terms in the demo, so useful to keep in mind. And then ultimately, lastly, is the concept of a wave. And a wave is simply a prioritized, ordered list of dependency groups or move groups. It is taking from my applications, going from my apps to my move groups to waves. Put simply, or more visually at least, this is what that looks like. So you start off with servers, I'll say, for the sake of simplicity, but it could be servers, it could be networks, it could be storage arrays, the underlying physical infrastructure, virtual infrastructure, that underpins your apps. It's then the case of identifying how this infrastructure underpins your apps and identifying what composes an individual application out of that set. Once you've then defined your apps, well, what apps have dependencies on one another, those shared databases and so forth. And then once you've got each of those move groups identified, you can see the colors correspond between move groups and waves. You then take those move groups, push them together. So, for example, you might want to move 10 move groups in one wave, or one move group in one wave. You might want to, as you gain confidence in your migration, start off with, say, one move group of 10 servers for my first wave as I dip my toes in the water. And then as I advance and get to my nth wave, I might want to be going up to, say, 150 servers per wave, 10 move groups per wave, and getting larger and more ambitious. And this feeds into the plan for your migration. You end up with something that looks, this is effectively visualized in PERT charts, Gantt chart kind of form, where what we have here is overall set of weeks. You can imagine this as sprints effectively, and then you've got the tasks that correspond to each wave being executed in series. So you're thinking about how do I go from my infrastructure to the wave plan and then to an execution of that wave plan. And something worth thinking about, just giving some guidance here, is as you do that planning, you want to think about your why and the reasoning for your migration, but this is typically how you put together your wave plan, is you're thinking about how do I achieve my objectives, think about my why, my reasoning. Generally, I start off with something that shows initial value. I want to start off my migration plan by demonstrating value, because recall, the migration plan is not a one-done, it's a perpetually moving and evolving plan. I want to start off my plan and execute some of it and show value to my leadership, to show that my migration plan is actually feasible and indeed works. And typically, you start off with some small but yet meaningful applications. So you don't typically want to start off with purely dev test or throwaway applications, because that doesn't necessarily prove anything. Anybody can move a server that doesn't have any users or an application that has no data. You want something that is small but actually has meaningful business value to it. And ideally, those are applications that have fewer dependencies. So if your dependency analysis did miss something, you're not going to break anything. And ideally, something that's maybe more latency tolerant or can tolerate some more downtime, so lower RTO and RPO, sorry, higher RTO and RPO requirements. Then comes, as you gain confidence in your migration and start to prove its validity, you start to get into more higher, complex apps, generally getting into the weightier parts of your application portfolio. Before then, as you really get moving in earnest, get onto those core mission-critical apps, the things with the low RTO and RPO, things that are more latency-sensitive, more technical limitations, and then progress until indeed you have completed your migration, evolving your migration plan as you gain insight and learning from each subsequent wave. You always go back, change the waves as you learn. And that is key to know because ultimately, as I've said, and I'll hammer on this point, migrations should be treated as an agile project. Something that I've seen many customers do is get into the thinking that a migration should be a waterfall project, that I'm moving from on-premise to AWS, that has a number of steps, so I execute in serial, I'm going to execute a linear project plan, but absolutely that's a good way to run into challenges because you need to be able to evolve your plan as things change, as you gain new information. It's important to think of this as a cyclical, agile process. And with that in mind, one of the biggest challenges that comes with migration planning, being an agile project, is that this is how we got used to planning projects. Ultimately is through staring at spreadsheets and Gantt charts and Jira boards and so forth. And the headache here is that it's so much manual work to track this. Think about that slide with all of the network dependencies, tracking that by hand, breaking that down, creating different tabs in a spreadsheet. I've literally seen 50 tab spreadsheets being used for large migration planning. And what's worse is that you end up emailing them around. So you end up with John's version -1, Susan's version -2, etc. So version tracking and maintaining all of that becomes a huge headache. In the era of generative AI, we can absolutely do better to plan and execute large migrations. So that is where we get to AWS Transform for migrations. So just as a quick show of hands, who is familiar with AWS Transform? Has folks had an opportunity to play with it, to explore? It's a relatively limited show of hands, hopefully. By the end of this talk, you'll all be familiar with AWS Transform, and you'll be enthused to go off and experiment with it because you will have seen, hopefully, a lot of the announcements that came yesterday, huge number of launches for AWS Transform, best-in-class generative AI capabilities for accelerating migration and modernization. So AWS Transform is an agentic AI service that encompasses a wide number of capabilities. So it includes migrations, which is going to be the thrust of what I'm going to be talking about, but it also includes full-stack Windows modernization, so being able to transform Windows, .NET, and SQL Server applications, mainframe modernization, so decomposing COBOL applications and moving it to Java, and then also, launched yesterday, is custom transformations. So the ability to do almost arbitrary transformations, things like programming language upgrades and framework upgrades, using custom transformations in AWS Transform. So I would highly encourage you to check out all of these suite of capabilities that really help you both with the migration side of things, but then also once you're on AWS to then modernize your environment. But where I'm going to focus is really on the migration side, starting with AWS Transform assessments. So AWS Transform assessments is a GenAI capability for generating a TCO assessment. So has anybody ever done a migration evaluator assessment or an OLA assessment? Does that ring a bell with anybody? Any show of hands there? Perhaps not. So these are ways that AWS has had for a number of years now, and they're capabilities that are human-led programs for building migration assessments. And they give a detailed assessment, but they're ultimately led by humans and take typically a week or so to get a result. AWS Transform Assessments uses agentic AI to automatically build an assessment, a TCO assessment. So what it does under the hood is generates code and programmatically does the assessment and then generates you an assessment output in a PowerPoint, PDF, and Excel format. So you can then take them to other tools, analyze them, and so forth. It is the fastest way in AWS to get a migration assessment. Actually, the fastest way pretty much anywhere to get a migration assessment. And it does currently any x86 compute, attached storage, object storage on premises to S3, and SAN storage to FSX. So broad set of capabilities there, and we're expanding it, adding more and more assessment capabilities there. So you can have a quick demo of what this looks like. So this is the AWS Transform console. Here we go. So what I'm doing here is I've created an assessment job, and it's asking me to upload data. So I'm going to throw some data at it. In this case, I'm going to throw an RV tools file. It takes a variety of different formats, but an RV tools file is a nice and simple format that everybody can get very early in the migration journey, typically. I'm saying what region I'm going to be in, and I'm going to choose Oregon there. I'm going to generate an assessment. So I'm going to skip ahead a little bit in this recording, but it takes about 10 minutes, and what it's doing is generating the assessment programmatically under the hood. So we wait a few minutes for it to generate, and then I've skipped ahead here. I'm going to click and then click Review. So what this is showing here in the right-hand pane is the assessment result. And this is it showed in the console, but this is it showing insights. You can see the compute, the storage, the annualized cost, the cost with a reserved instances, and it goes through all the assumptions that I've generated here. So it goes into the detail about how it was calculated. Now, something that's kind of piqued my interest here is that it's using dedicated hosts. So I'm wondering, why did it use dedicated hosts? That's not super common to use dedicated hosts. So I'm just going to ask the chat, why did you recommend dedicated hosts? And what it's going to do then is it has a knowledge base built out of all the assessment data, the data that you provided it, and it will go through the math and then figure out, well, why did I recommend dedicated hosts? And what it's going to explain is that you had a set of Windows licenses that looked like you could optimize the costs using dedicated hosts, and then it did the math to bin pack those Windows virtual machines onto your dedicated host to get you the best cost effectiveness, and that's what it's explaining there. And you can ask it a number of different types of questions. So it's explaining the BYOL, bring your own license math, that's there. And then once you've done that, you can look at the exports that it generates you. So this is the same data, exactly the same thing, just in PowerPoint format. So I'm just skipping through it very quickly here. But same numbers, math. So if you want to share that to your stakeholders or to your leadership, you've got a nice collateral generated there that's just easy to take. You also have a number of other different formats. So the other one that's most useful is spreadsheet outputs. You can take all the math, you can throw that into other tools, visualize it, do whatever you want with it, so you can see all the raw assessment data. And then lastly is PDF. Now, the last step that it gives you is that you can then transition to migration execution. So what you just saw there that went by quite quickly is that you're now in, it says, welcome to AWS Transform, I can help you migrate to EC2. What just happened there is it takes the data from the assessment and then populates it into a migration job. So then you can go into more detailed planning and do all the dependency analysis and migration planning that I'll show you next, but just nice feeds through to the next step. So what comes in the next step is AWS Transform for migrations. So yesterday on Monday, we launched a huge series of new capabilities for AWS Transform for migrations. So if you've ever used AWS Transform previously, we've hugely overhauled, completely replaced the existing migrations experience to add brand new capabilities that we are very excited by. So this is what the AWS Transform for migrations flow looks like. So it starts off, and potentially unsurprisingly, this correlates quite closely to what I've described earlier, indeed built that way, that you start off with discovery, taking the on-premises data, you go through migration planning, and as the focus of this talk is migration planning, I won't get super detailed into the later steps, but network migration, so you can take your on-premises networks and move them to AWS, and ultimately execute your migration. So this is a bit more of a detailed explanation of what each steps does of the AWS Transform for migrations capabilities. And something actually is particularly novel that isn't going to be a focus of this session, but I'd encourage you to look into, is the network migration piece. That quite commonly, you have to migrate a network from on-premises to AWS. You're not building brand new networks. You're wanting to move your existing applications, existing networks over. What we can do is to take existing networks from on-premises via a VMware NSX through basic RV tools networking that includes vSwitch information, through Fortinet, FortiGate, Palo Alto, and through Cisco ACI. We can take exports in those formats, analyze them, and then generate VPCs, subnets, security groups, route tables, transit gateways, all of that infrastructure from the on-premises network. So rather than have to manually translate all of those networks, you get that done for you with agentic AI, which is super powerful. You can also edit those CDK, generate CDK, CloudFormation, and Terraform. You can edit those manually. You can pipe them into something like Q Developer or into Kiro, for example, and further modify them. So where we're going to go next is to look at those capabilities in AWS Transform for migrations and see how they can help accelerate your migration plan. So where we're going to start off with is with discovery. So that's some examples here of discovery data that you will typically want to use. The best practice here ultimately is to use a combination of different data sources. What you don't want to have is purely technical sources. You want a combination of technical and business sources, because ultimately you want to be able to understand the why, the meaning behind your environment. I might understand that these are servers. These servers all communicate on port 80 and port 443 and what have you, but why do these servers exist? What function are they underpinning? What's their criticality? What should I reason about them as I go through my plan? And that sort of business context, the sort of business logic that informs why they exist is important to take in. And we can take that through formats like CMDB data or meeting notes or wiki page dumps. Anything that gives that kind of context, we can ingest. So what that looks like is that you have, as you can see on this bottom left here, an upload pane with an AWS Transform where you can throw data into. And it's literally that simple, as I'll show you in just a second. You take your data, throw it in there in a wide variety of formats, and we will slurp up that data. Now, one thing that I want to highlight as well is that often getting technical data can be something of a challenge. Getting things like process data, inventory data, networking data may rely on third-party tools or having to use a combination of different tools. We've made that simple by creating the AWS Transform Discovery tool. So this is a network-based collection tool. So it's installed as a virtual machine into your on-premises environment, and then collects using a variety of protocols like SNMP, SSH, WinRM, data from your environment and maintains it centrally, and then outputs a file that you can upload to AWS Transform. Critically, that file is independent of any network traffic, so you can run it in a completely isolated network environment. No route or communication is necessary back to AWS, so it can run in isolated environments. So let's look at the discovery tool very quickly. So this is the discovery tool. This is running on premises in a local environment, and this is its local web UI. It's very simple UI. And what it shows here is the data that I'm giving it. So I'm giving it a different set of SNMP credentials and SSH credentials that it's using to pull from the environment. This is just a test lab that it's running in. But what it's doing is pulling from this environment 1,000 servers or so. You can see there it only collects database data from Windows SQL Server right now, so it's not supported there. But you can see the majority of servers it's pulling network connections from. It's got a few errors that I need to resolve, but it reports that information and then gives you an inventory file that you can then download and then throw into AWS Transform. So what I've just done, literally the process of setting up this by deploying a VM and then downloading the file takes about an hour end to end to get basic information. And here I've got a spreadsheet filled with rich network data, process to process. So I understand, for example, that I've got curl running on this server, communicating over HTTP to this server, and HTTPD is running there. So I get this rich network trace to inform my dependency analysis. And this is available without charge, as indeed all of the AWS Transform migration experience is, and is a very powerful tool for getting data in. Now, once I have data, either from the AWS Transform Discovery tool or from alternative sources, it then becomes the case of getting into AWS Transform. So what I'm looking at here is the beginning of an AWS Transform job. Now, this is a migration job, and what I'm going to do for the purpose of this session is simply do migration and planning, discovery and planning. I can do an end-to-end job or just network migration, a whole host of different permutations, and you can add and remove job steps at any time. Now, what I'm going to do here is that I am going to throw in a whole bunch of information here. So it's saying these are my 2 steps I want to do, import inventory, and then build migration plan. So I'm saying, looks good, it's going to create the job plan. You can see it on the left-hand side, it's created there. And what it's now going to move forward into is awaiting user input. So it's awaiting my data. Takes a second or so. And now it's saying you can upload data using this file upload. I'm going to click that file upload. I'm getting a little ahead of myself. Go on, go click. And then there's the upload dialog box. And what I'm doing is just taking all of these files that I've got sitting on my desktop and uploading them. And we'll get into what those files are in a second, but those files are just a whole random spattering of files. Some of those files are, you can see CMDB export in there, discovery tool export. It's a whole mixed bag. So we'll jump onto that in just a second, but I just told it to, looks good, go forward with it. And what's going to happen is that a combination of traditional parsers and then AI agents are going to go analyze all this data. So you can see we've got some data from the discovery tool here, an RV tools file. That is an arbitrary CMDB style data mapping apps to cost centers and users. This is a file that's a Zoom meeting recording that's got a whole bunch of people just chatting about what their migration is and what they're going to do, completely unstructured. This is an export from a wiki that I put into Markdown format. And I'm just throwing it up there and asking the LLMs, the underlying agents, to then analyze this data and make sense of it all. I don't have to mix formats and manage spreadsheets. I just ask the AI agents to figure it out, and that's what they do. And you can see once I've uploaded a quick summary, I've got 1,300 servers or so from this import. This is my breakdown by operating system. This is my app catalog that's figured out. These are my common network ports. I can see a lot of SSH connections. I can see MongoDB in there, HTTP. I can identify some apps, and it gives me a view of all of my applications. So from those meeting notes, it's figured out, here's a bunch of apps that are in focus. From the AWS Transform discovery tool, it's got all the network connections and process data. And there's my raw server list that I can get. And I can export this all if I want. But literally built out very quickly a pretty detailed view of my environment from just arbitrary files that are pretty easy to get. So once I've got that, I can then start the planning process. And again, I can come back to this at any time. But let's move on to the next step, which is planning. And you can see now I've moved on a little bit. I've added some additional data, and I've skipped to building a migration plan. And what I'm doing here is trying to build up my app catalog, understand what apps exist in this environment. So what I'm doing here is looking at my inventory as it exists right now, and it's giving me similar to what we just saw, but a little bit more detailed of adding more servers to it. And I've noticed something, for example, that I uploaded a bunch of data that had a whole bunch of powered off servers because the data was messy data. Now, the agent didn't want to just remove those servers because that could actually be important to me. But what I'm going to say is, well, actually, I want to get rid of some of this data. It's showing me, here's some questions you should think about. For example, should I get rid of powered off servers? Should I normalize the data? And what I'm saying is, those powered off servers, that's just messy data. Let's get rid of that. So it's going to clean up that data for me. And then it says, well, I've gone down from 5,000 servers to around 1,200 servers, filtered it all down, and cleaned up your environment for you. And you can do any arbitrary data processing that you want here. You can do, say, I want to remove servers based on a hostname pattern, or I want to remove servers based upon being in this data center or being on this subnet. I want to add more servers. Here's a list of the servers I want to add, or here's another file I want to add to them. And you can see here it's saying, I want to go to app grouping now is my recommended next step, now that your data is a little bit cleaner. But before I go into app grouping, I'm going to ask it some questions. So one question I'm asking is, for example, describe my network architecture. And it's saying, here's some notable things. I can see LDAP is common in your environment. Everything is speaking to the LDAP server. You've got one single LDAP server. You might want to make that more fault tolerant. AWS Directory Service would be a good match for that. You've got 4 primary database types in your environment. Notably, you've got a single SQL server in the environment, a little bit odd. And you can see that this is your network topology at a high level. You've got some key subnets in there. It's generating some initial insights as to what it thinks your waves could look like. And it's asking questions about how you want to go about and do application grouping. Now, I saw that LDAP server getting mentioned, so I'm going to say, what is that primary LDAP server? You mentioned everything has a single point of failure, so it says, well, here is your LDAP server. It's LDAP primary test lab. It's my test lab server. And it gives me information about its role in the environment. And I can ask pretty much any arbitrary question. As long as I have the data for it, I can ask questions about it. So if you have software catalog saying, this is my SAP environment, or you've got inventory about what is running on each web server as a web app level, you can ask your questions about any of this. So after I've done that kind of data curation, Then it goes on to app grouping. So what I need to do is ultimately get my servers into apps. So what it's saying here at the start of this is that I can notice you've got a common set of hostname patterns, that you've got common dev, test, prod names in here. I can see from your meeting notes and your calls that you're talking about different environments. So it's asking some information to figure out that. And I'm going to paste a whole bunch of things in there that is answering these questions. So I'm saying, for example, that I have 2 primary facilities, one in Vancouver, one in Seattle, and they have different hostname patterns. This is how I identify each app, and this is how I identify if it's dev, prod, test, etc. from its hostname convention. And I'm also asking it to consider network traffic. So I'm asking it, for example, group anything together with tight coupling, like database dependencies, but then separate anything out that has, more latency tolerant HTTP dependencies. And I'm saying, don't split app tier. You might want to have your database and web tier separate. I don't. It's one app to me. It asks some clarifying questions, so I'm trying to execute what you're working on. I noticed some things like, for example, some servers have hostname patterns you're describing, some are uppercase, so lowercase. So I'm like, just ignore that, I don't care about it. But I could say, actually, it means something semantically significant, so I can inform that. It's asking about unknown prefixes. Should I create new apps for prefixes that don't correspond with anything you're talking about in your meeting notes? So the wiki pages and meeting notes I gave mention certain apps, and it's correlated the host names to those apps, but there's some that don't match. So what I'm going to say is to just create a new app for it. And I'm saying other things like if it's an app server and a web server, just treat it as an app server. In my world, app and web means the same thing. So I'm just giving it some additional context, and it's figuring out all the intricacies of my environment. So it's a purely chat-based experience. And what it's saying here is that I've done my app grouping, I've ended up with 486. It's a nice number. Apps, I can break that down more. It's identified quite a few single server apps because they don't have network traffic, so they look single server, but I could break that down further with more information. And it's asking how I want to prioritize those apps. So do I want to assign a priority to different apps? Are all apps equally prioritized? Probably not. So what I'm saying is that I want to prioritize environments. So for example, I want to move my dev and UAT environments before my prod environment because I want to make sure that those environments work correctly first. I'm saying that I have some things like the actual data collectors that gathered the data in that data set. So just remove those because they're noise, and you can change the scope at any given time. And then I'm just answering some of the other questions I'm asking. It's asking about complexity and so forth. So I'm giving it those answers, and what it does then is basically produces a final app list. And it's saying app structuring complete. Here's my list of apps. It's happily named most of them because it's got the names from all the meeting notes that I submitted. And it's figured out some other names that we don't have good data for, like test cluster. It's kind of made up the names, but you can say, actually, that test cluster is called this, and it will appropriately rename them. And then it's building out an incremental kind of plan that it still needs more information to refine, but it's getting closer to a final plan. What it asks next is move groups. So that is, as we recall from earlier, move grouping is that dependency analysis phase where we group all the apps together. And this is, I'm just going to go through this one quite quickly. What this is doing, you can see regenerated. I skipped ahead a little bit, but I basically told it, group everything together on network dependencies and do that analysis for me. And it's done an initial grouping. But one of the things I've noticed is that it's saying, and one of the things I gave it in a bit of an earlier conversation was some information about my teams and my capacity for delivering my plan. And I'm noticing, wait a minute, some of these numbers don't look great to me. You got weeks 1 to 6, you got weeks 7 to 8, and you're saying there's certain timelines implied here. I don't love that because I'm on a timeline. One of my constraints is timeline constraints. So I'm asking to, how do I change my move groups to move faster? And it will go forth and do that analysis and figure out, well, actually, given your timeline constraints, I could change some of my move groups, balancing risk and speed, and make some changes. So, for example, it's saying combine dev, UAT, alpha, and beta, because they're all functionally reasonably similar in terms of their behavior. Group that together, and make the groups larger, parallelize them out, and then you could actually meet your migration target within the timelines. So it's coming up with ways to accelerate your migration plan, changing its strategy dynamically on the fly. And you can ask it about any constraints that you want to employ on your migration here to meet those constraints. And I was asking some other things here that we'll skip through a little bit, but I was asking, tell me more about your timelines, your risk tolerance, things that you want to focus on. And I'm saying, ultimately I want to focus on the 6 weeks. I want to balance risk tolerance, and it goes forth and figures that out. But yeah, it regenerates that. In the interest of time, I'm going to skip forward on that one. Once it's generated the final move group, so analyzed all those dependencies and come up with a plan, what it then generates is the wave analysis, the wave plan. So that is ultimately taking those move groups and then prioritizing them into an ordered, prioritized set of waves. So what it's going to ask for here is information on the business prioritization, the business logic in here. Now, it's been able to glean a lot of this from the information that I gave it. The more information you can submit, the more it understands, the less it has to ask you. So I'm giving it some general information here. I want to start with minimally complex apps. I want to save my products to the very end. LDAP needs to move first because we knew LDAP's a critical dependency. And it comes up with a general high-level plan for ordering these waves. It says these are my phases to move each waves in. Here is the servers within each wave. Here's the move groups within each wave. And it breaks it all down for me. What you can see at the bottom there, if it wants to scroll down, is you can see some of the key metrics. So it's achieving the 6 weeks. It's saying these are the resources that I used. I told it about the people I have to execute my migration. It's talking about the max servers per wave, the time savings, and so forth. And I can ask it for arbitrary breakdowns of the grouping. I can change its priorities. I can do anything that I want, really, to change my plan. And then ultimately, what I can do is finalize this plan to the execution and go forth to my network migration and to my rehost. But at any time during my execution, I can come back to this plan. I can say, well, actually, wave 18 didn't work out so well. It turns out I missed a key dependency. I want to go back there. Or my leadership is saying go faster, so I actually need to come up with a different parallelization strategy, or I need to find other ways to accelerate. So it's an iterative process. You can at any point go forth and refine the plan. And lastly, I'm asking, give me some backlog that I could populate my sprints with, my backlog with, and it generates some ideas as to here's the task that you need to do to be able to actually execute this. So you can then basically take your wave plan and do that final step of planning, populating the agile plan out, and then begin to set up all of that mechanism and process to then start delivering your migration. All right, so we've got a few minutes left. That has been a bit of a whirlwind tour, but that is the discovery and the planning experience within AWS Transform. So that is effectively going from high-level, rough data in many different formats through to analyzing my environment, doing the dependency analysis, applying business logic to prioritize, and then producing an executable ordered wave plan, and then generating ultimately a set of very high-level stories that I could then start to use to inform my agile plan. This typically is something that we see customers execute in months. It's a long-term process. This is something that you can now move to literally building it in minutes, hours, but in a real-time scenario, this is something you always come back to and you're always refining, but still something that you're doing orders of magnitude faster than what you will be doing if you were doing this by spreadsheets and manual analysis. So we think this is really changing how migration planning will be done in the future. All right. And now over to you for the conclusion.
Thanks. Yeah, so you saw the advantages of using generative AI and an AI agent. This is when I knew a couple of weeks back that we really built something very, that's going to be really useful to customers. What Jonathan showed you is he was asking a lot of different questions to this agent. None of those are questions that we've programmed the system for at all. It's figuring it out on its own. So this is when I knew a couple of months back when a customer was using this, on a trial basis, this wave planner, and they randomly asked, hey, group all my, and they had like hundreds of applications, create a wave so that all my security-related applications move together. Not something we've programmed for, but when that question was asked in front of the customer, it figured out which applications related to security, figured out which servers those had dependencies on those applications, and generated a wave group that was appropriate for that particular request from the customer. So that's the advantage here is that when you use AWS Transform and this wave planning agent Jonathan just talked about, you don't have to wait for us to add new features that meet your use case. Now it's intelligent enough to listen to your use case, take your own data, and figure out how to solve it on the fly instead of waiting for the service team to launch new features with it. That's the advantage of generative AI here. Best practices for migration planning, we've covered it all. I'll recap it one more time. Again, automate with agentic AI. Don't try to manually plan. Spreadsheets are dead. You don't need them anymore. We've got artifact store within AWS Transform. The agents, as it works on your data, it will generate assets. If you want those assets, you can download them and take them with you, but you don't have to be the one working with those assets and spreadsheets and CSVs. The agent will do it for you. Iterate. Migration is never a one-shot deal. It should not be. Large migrations, complex migrations take time. So because now an agent is, by the way, going back to that customer about security groups, their response was, hey, what you just showed me live here on the meeting would have taken me weeks, if not, a couple of weeks to get done manually, and you just kind of ask the question and get it done. That's the advantage of iterating here is like, because now with an AI agent and generative AI, you can do so many things so fast, it can think on your behalf really fast. You can iterate quickly as well. You don't have to worry about trying to get everything right the first time along. You can go along, come back, restart, and reset and iterate over and over until you see something that you like. Understand the technical and business dependencies. Combine as many. You don't have to worry about, hey, I'm using this software. It only takes data in this format or that format. Jonathan showed you, he was dumping all kinds of meeting notes and you name it, all kinds of data into the agent, and it was able to extract information out of it and use that information to generate your migration plan. So for the first time, you don't have to feel bound by the kinds of files this tool accepts. Just throw everything you've got at it and see what happens. Not saying it'll get everything right in the first time, but then that's where iteration comes to your rescue as well. And lastly, gradually increment, start with low-risk waves, move small numbers of servers, and as you gain confidence, increase the wave size and increase your confidence. We only talked about discovery assessments and migration planning today, but AWS Transform, once you have the plan, you can go ahead and generate networks, you can move your servers, you can execute the entire migration end to end. This session simply focused on the migration plan, so you should, once you go back from here, consider using it for a small data set, doing an end-to-end migration. So to conclude, you can now, with this kind of agentic AI, I would say 4x is even underselling it a little bit, but you can migrate large enterprise workloads at least 4 times faster with agentic AI. You don't need to use spreadsheets anymore. You don't need to use any kind of files. Just use natural language to interact, and the agent will create the files for you. Take the undifferentiated heavy lifting out of your migrations and de-risk by automating dependency analysis and wave planning. There's no need to do it manually. Anything that you do with this agent, you can ask it to generate a detailed report if you need to take a report for auditing purposes internally to your IT department or your leadership or legal. The agent will give you a detailed report of the plan, or if you choose to execute what it did with the network migration or the server migration, you can take those reports, print them out, and use that for auditing, but you don't have to be the one to be doing all this manually. And with that, we'll open it up for questions.